next speaker. It's Darren Langley, who is the General Manager for Rocket Pool.
Thanks again. All right. Hey everybody. I'm Darren Langley. I'm from Rocket Pool. So Rocket Pool is the second largest liquid staking provider. We're a decentralized liquid staking provider. So we have over 3,000 independent node operators in about 100 different geographic locations. We account for about 3.5% of all of the ETH that's being staked today. So today I'm going to be talking about EIP-4788. It's kind of like an obscure and small EIP, but it has a major impact on the staking space. And in fact, as a staker, you should be very excited that this EIP is going to be coming next year. So I should have jazzed up the title a little bit. This is a better title. The name of the EIP is a bit generic, but this goes to show that it is actually a big deal. Okay, so what does EIP-4788 solve? Okay, so currently there are still really, from a smart contract perspective, there are still really two chains. We've had the merge, and that's fantastic. But from a smart contract perspective, the smart contracts don't know about anything that happens on the consensus chain. Right? The smart contracts live on the execution chain, but they have no visibility of what goes on the consensus chain. Now, in most cases, this separation is actually a good thing, right? But for staking applications and staking protocols, this is it poses a bit of a challenge, okay? So imagine a staking protocol, and there's a staking protocol here in orange. You'll notice that. So this staking protocol is a bunch of smart contracts sitting on the execution chain, okay? And the issue is that it needs to get information from the consensus chain, but it can't. So staking providers or staking protocols, what they do is they implement an oracle, all right? Now the oracle transfers information from the consensus chain to the execution chain, inputs into the smart contracts, so the smart contracts have that information. The issue is that the smart contracts have no idea whether what the oracle has given them is actually the right thing, okay? They have no way of verifying that they've done that. So in a staking protocol situation, the oracles have to kind of like we have to rely on like an honest majority or like reputation or some sort of social leverage to make sure that the oracle is doing the right thing. Now, that sort of oracle system works well enough, but it's not ideal because we've introduced some sort of level of trust in the system, and which we don't want to have. The other big problem with having these oracles is that they can become gatekeepers. So they're needed. Let's say, for example, that you need a participant that submits some data, and you need an oracle to then check that data to make sure it's correct from the consensus chain point of view. Then they become gatekeepers, and you don't want that either. Okay, so what is EIP-4788? So what it does is it provides trust minimized access to consensus information. So it helps staking protocols, restaking infrastructure, some MEV applications, and to be much more efficient. It also promotes a lot of innovation within the staking space. The amazing thing about this is that it is coming next year. So Denkun is kind of in testing at the moment. They're going through the hard forks on the test nets, and so that will be available next year. As somebody who kind of builds or helps to build a decentralized staking protocol, I cannot wait for this to be in Ethereum. It opens up so many opportunities, and as a staker, you should be pretty excited about the future. And we'll get into that in a minute. So, how does it work? So, the consensus block has some really interesting information in it, okay? It has validator statuses, or well, sorry, the state root has lots of information in it. So it has the validator status, has the validator balances, whether validators have been slashed. It has exits in there. It also has a lot of performance information as well. Now, what they do is there's a Merkle tree that contains all this information, and that's all bundled up into this hash tree root, which is at the top. So this kind of like string is the root that you can then use to verify any piece of information within that block. So in other words, you can verify from that hash tree root, you can write a proof that verifies any piece of information within that within the consensus kind of block and block state. So EIP-4788, what it does is it puts the consensus block root in the execution block. Technically, it's the parent of the consensus block, but I'll skip that because it's complicated. So that's now available within the block. This isn't that helpful, particularly for smart contracts, because ideally, from a smart contract perspective, you want to be able to get a block root for a particular time period or at some point in the past. And so that's not necessarily as useful, but it becomes a bit clearer in a minute. Okay, so along with that kind of like beacon state root in the execution block, you've also got a new smart contract that's going to be deployed called, it's actually called the beacon root contract, but for consistency I've called it the consensus root contract. The idea behind this smart contract is it enables any smart contract to be able to query for an individual block root. And so you can essentially give it a time, and it will give you back what that block root was at that slot. One of the things about this contract is it uses this thing called a ring buffer, so that the state doesn't keep growing and growing and growing. That ring buffer lasts for a day. So essentially what it means is that you can query block roots for within like 24 hours or a day, okay? How the block roots actually get in there is, so now I've got to remember, the consensus clients, or execution clients, sorry, the execution clients submit the block root each time it executes a block. And so they actually put that in there so it's available for querying. All right, let's give you an example so that you can kind of like see how all these pieces work, right? So let's say, for example, we want to give a NFT to anyone who's been on validating on the beacon chain for over a year, all right? So the idea here is that some validator would call this mint function on the NFT. They would provide a proof to and the values for a certain information, right? So they would provide the withdrawal address for the validator, the activation epoch, and the exit epoch, and they would call this function from the withdrawal address, okay? So that you can kind of link that it belongs to that validator. What the mint function will do is it will go to the consensus root contract. It will get the consensus root for that particular slot. It will then use that and this proof, or will actually verify this proof against that root to make sure that those values are as expected. What it'll also do is it'll check the signature to make sure that it's from the withdrawal address, and then you can prove that the person who's submitting this is actually the owner of the validator and that they have been validating for more than a year. And at that point, you can then issue them with an NFT and everything's great. So this is a bit of a trivial example, but you can actually take the basic concepts of this, translate it into staking protocols, and you get massive impacts for the state of staking today. So, what are those impacts? So, what the future looks like is you start to become a lot less. There's a lot less trust. So, at the moment, these staking protocols need these oracles, but with this beacon state root, we can essentially get rid of those oracles and replace them with trustless processes instead of like processes that use trust. So what that means is you can actually move it from these kind of like trusted actors to participants of the network. So in our case, for example, moving it from oracles to our node operators. Because it's trustless, you know, a staking protocol shouldn't really trust the node operators, or at least a decentralized staking protocol doesn't trust their node operators. And so we have to have these trustless processes for it to work. So what this does is it introduces that. So it means that there's no need for these trusted kind of oracles anymore. The other thing is efficiency, and this is probably where, you know, from a staker it becomes a little bit more interesting. It becomes a lot more efficient and a lot lower costs because the information is we can verify the information a lot quicker. We don't need these oracles to send over the information. It can all be done in a kind of a trustless way by somebody submitting the information themselves with a proof, and then we can verify that is absolutely correct. It also there's a lot of efficiency improvements within that. So you know, from if you're a liquid staking token holder or if you're a node operator within these staking protocols, this is going to make a big deal to you. The other thing is around innovation. So, you know, there's a great opportunity to improve the current staking protocols, you know, that exist today, but also whole new types of staking protocol or different ways of kind of doing this similar thing, but in a much more efficient way. Okay, cool. So, what are the resources? So the EIP itself is actually quite approachable. I'd kind of recommend having a read. There's actually a brilliant series called Peep and EIP from the Ethereum cat herders. This one in particular has Alex Stokes going through the design decisions around EIP-4788, and actually a big shout out to Alex because he's kind of pushed this EIP very, very well. Yes, thank you very much. Long story short, EIP-4788 is going to change the staking landscape. It's a very important EIP, even though it's a very small one. But yeah, be excited for the future. That's me. Thank you.
We certainly have times for any questions here. I see some.
Hey, thanks, Darren. Can you just explain again the purpose of the ring buffer in the contract?
Yeah. So so basically, we don't want the state to kind of like grow and grow and grow, because it means that that's going to cause a lot of chain bloat. So the idea behind this is to have a ring buffer that keeps it to just a day's worth of block routes. In general, a day is perfectly fine. You only really need it for a few. You need enough time for like a few blocks maybe to make sure that transactions can go and get processed. But in general, you know, a day is ample for this sort of application.
Any other questions? All right. Well, once again, Darren, thank you very much for an excellent presentation.